Welcome to the video, guys. Today we're going to be synthesizing methyl salicylate from salicylic acid and methanol. Methyl salicylate is a colorless and viscous liquid that's found in many species of plants. It's commonly used as a flavoring agent and as a fragrance due to its minty smell and taste. As you can see from this reaction, salicylic acid and methanol react and form methyl salicylate and water. Phosphoric acid acts as a catalyst. And this reaction is an equilibrium reaction. So to sway the reaction towards the products, we're going to have to increase the temperature and increase the amount of methanol used in the reaction. Here's the structure, and here's a 3D look at the structure of methyl salicylate. Gloves and protective eyewear should be worn at all times, and this reaction should be done under proper ventilation since methanol vapors will be released. The equipment includes 25 grams of salicylic acid and 150 milliliters of methanol. These two will act as reactants, and 20 milliliters of phosphoric acid, which will act as the catalyst. 100 milliliters of distilled water, which will be used to separate out the final solution. Step 1 is to add 25 grams of salicylic acid, 125 milliliters of methanol, and 20 milliliters of phosphoric acid to a flask. First, I'm going to add 25 grams of salicylic acid to the Erlenmeyer flask. Now I'm going to add 125 milliliters of methanol to the Erlenmeyer flask. Okay. And now I'm going to add 20 milliliters of phosphoric acid to the flask. And this should be done slowly while mixing. The solution is starting to fizz up now that I'm adding the phosphoric acid. And now I'm just going to mix it a little bit. Step 2 is to heat the solution for an hour while slowly adding 25 milliliters of methanol. Now we're going to heat up the solution for an hour in a hot plate to help the reaction take place. And we're going to be adding 25 milliliters of methanol during the reaction since a lot of methanol is going to evaporate. The solution has been heating for around 15 minutes now. Since some of the methanol has evaporated, I'm gonna add some more to the solution. Step 3 is to let the excess methanol evaporate. The reaction has been going on for an hour now, and now I'm going to let all the excess methanol evaporate by turning up the heat a little bit. Now that all the methanol has evaporated, we have some crystals that have formed at the top, and we have a final solution, but we still need to separate out the methyl salicylate. Step 4 is to separate out the final product using 100 milliliters of distilled cold water. Now to separate out the methyl salicylate from the solution, we're going to add 100 milliliters of cold water. Since methyl salicylate is not soluble in water, it will be dense and form at the bottom, and then we can separate it out. Okay, and now we're just going to add 100 milliliters of the cold water. Some foam is forming at the top, but eventually the dense methyl salicylate should be forming at the bottom. And we're gonna have to let this sit for a little bit and mix it. As you can see, the solution has become very thick, and I can already smell some mint coming from it, and smells kind of like candy. Now the solution isn't separating out completely, so now I'm just going to pipette some of the solution at the bottom into a test tube. And now this is our final solution of methyl salicylate. And there's a really strong minty smell coming from it. So the reaction worked. So the limiting reactant of this reaction is salicylic acid, and we started with 0.181 moles of salicylic acid. So the expected amount of methyl salicylate is 27.539 grams, but there was no point of really calculating the percent yield of our reaction since I was never able to separate out a pure solution at the end. Thanks for watching, guys. Don't forget to like, subscribe, and hit the notification bell if you enjoyed the video. And feel free to ask any questions in the comment section. I'll see you guys next time.